Okay guys, so today we're going to be graphing quadratic functions, and we have already figured out some important pieces about graphing quadratic functions, such as how to get the x-intercept, how to get the y-intercept, but now we need to talk about how do we get that bottom piece, that what's called the vertex. So just some little notes here. Quadratic is a nonlinear. It creates parabola, and a parabola is a symmetrical about a center line, which is called your axis of symmetry. And your axis, once you find your axis of symmetry, it gives you 1 point of the vertex. It gives you your x point of the vertex, your x coordinate. So if you notice here, up in this key concepts box, you have your standard form of a quadratic formula. So ax squared plus bx plus c. And then you have this axis of symmetry, which is x equals the negative b divided by 2a. Okay, and once you have your axis of symmetry, you can then find your vertex point, which is what I'm going to show you. So just some other information is that when your a is greater than 0, that means your graph is opening upwards, and your lowest point, or your vertex, is called your minimum. And when your a is less than 0, the graph opens downward, so it looks like it's negative. And the highest point is your maximum, and that highest point is also called your vertex. So your vertex is your maximum. So just want to give you 2 examples here. Two examples where we're graphing, where you have to find your vertex, your axis of symmetry, as well as your y-intercept. I didn't have you find your x-intercepts, especially for these graphs, because they're not exactly perfect. So your vertex obviously would be equal or easy. Feel free to pause at any time so that way you can try this yourself and then check your answers. So clearly your vertex is going to be right here at 2, negative 2. Now your axis of symmetry, just putting axis of sim, that would be your, so your symmetry would be a vertical line. So where would that be? That would be at the equation x equals 2, or your x coordinate from your vertex point. And then the last thing you have to find, again, another fairly easy point, is your y-intercept, which, where does this cross the y-axis? It crosses it right here, so that would be 0, 2. Fairly easy. If you want to pause now that you've seen that one, and I will just put the answers up for the second one. Okay, so there are your answers. Hopefully you checked it. You got it correct. Yay, let's move on. So now I'm going to go where I have, I'm giving the quadratic equation in an equation form. So this is already FOILed out or multiplied out for you. The linear equations are already multiplied out. So we're just going to give some information such as your y-intercept. Okay, we know that our y-intercept, when we plug in zeros for these x's, we get negative 2, or it's always your c term. So your y-intercept is 0, negative 2. Now for the axis of symmetry. You're going to use that little equation, x equals negative b divided by 2a. And now that it is in standard form, we're just going to take our numbers and plug them in. So x equals, b is negative 8, so negative 8 would be positive 8, divided by 2 times a is negative 2, which gives me 8 divided by negative 4, which is negative 2. So my axis of symmetry is at the vertical line x equals negative 2. And now that I know my axis of symmetry, I could find my vertex. And I find my vertex by taking my x-coordinate from my axis of symmetry and plugging it in to the function. So I'm going to take my -2 and plug it into our function. Oh, I forgot my square there. So I end up with 4 times 2 is -8, plus 16 minus 2, so that would be 8 minus 2, which is 6. So my vertex point as an ordered pair would be -2, 6. Okay. Again, if you want to pause the video at this point and try the next one on your own, I'm not going to talk through it, but I'm just going to put up the answers. Okay. Now we are going to go on when you have your linear functions. So at this point, we have our 2 linear functions that have not been multiplied to create our quadratic. So we're going to have to do all of that. So the first thing we want to do here is FOIL, first outer inner last, or multiply, distribute, whatever it is you want to call it. So I know that I have x squared, so it's first. Then my outer would be plus 2x. My inner would be minus 4x, and then my last would be -8. Combining my like terms, I have x squared minus 2x minus 8. So I'm going to do the same things in order to graph, except for the only thing I want to add on to this is also the x-intercepts, which we did on, I think it was Friday. So we have our y-intercept, that's the easy one to get. That would be 0, -8 by looking at our c term in the quadratic function. So now for my x-intercepts, remember from Friday, I'm going to take each of those linear functions, so x minus 4 and set it equal to 0, and x plus 2 and set that equal to 0, because again I want my y to be 0 to figure out what my x is, and I get x equals positive 4 and x equals -2. Because this is a parabola, I am going to have 2 x-intercepts. Real quick, I'm just going to graph these. Now, of course, it would be off the chart. Go figure, why not? So just a little bit of a roundabout. So there's my 0, -8, my y-intercept. Then I have 0, 4, and 0, -2. So you can see it starting to form. Remember that your y-intercept is not your minimum, so don't think that that has to be your lowest point on your graph. Next, we're going to do our axis of symmetry using that -b divided by 2a. So -2 would be positive 2 divided by 2 times 1, which would give me 1. So my axis of symmetry is at x equals 1. So if you want to put that in, I like to put a little dotted line to show that that's my axis of symmetry. I've got to go all the way down. And now that I have my axis of symmetry, I could find my vertex by substituting in that 1 for in my function to get my y coordinate. So 1 squared minus 2 times 1 minus 8. 1 squared is 1, minus 2 minus 8. 1 minus 2 is -1, and -1 minus 8 is -9. So my vertex point is 1, -9. Again, that would be off the charts. Go figure, just my luck. And it's about a roundabout right here. And now that we have these key crucial points, we can just roughly sketch what my parabola will look like. And Again, it's not going to be perfect, but it's a rough sketch, so I'm going to come around here to get to my y-axis, and then I'm going to come on up, and at some point hit this x-intercept. Don't mind this crazy line. The alignment is a little off on this Promethean board. And then it comes up something like that. And we put arrows on the end to show that it goes on forever. And then we do the same thing on the other side. Now, a parabola is symmetrical, so you want to try and make it look symmetrical. I am not very good at that. I usually have to flip my paper all around and do some crazy little things. And then it comes up. Yeah, you get the idea. And there is my parabola without using Desmos or the graphing calculator. For your next example, I will put the answers up. So if you want to try it on your own, you feel free to do so. I am just going to post the answers. And I can't get 17 on here. It's somewhere up here. You get the idea. And then your parabola is a downward, showing negative, something along those lines. Okie dokie, so that is it. I will also post this as a PDF on the Google Classroom so you can see all the answers and not have to keep flipping back and forth to the video. Do your best on the review, and hopefully we'll be able to quiz tomorrow. Good luck.